We now have, if you've never heard the one about the biochemist and the blogger, you're about to hear from Henry Auer right now. Let's give it up for Henry. I want to talk about global warming today. This is my blog. This is my address. Anyone who's interested,
hold the mic closer.
Lots of cars.
Unplugged. I am now unplugged. And my slides are running away.
Yes, so invisible energy. Our energy is out of sight and it's out of mind. You take your...
You need to hold the mic very close to your mouth, otherwise people won't hear.
You fill it up with gas, 15 gallons, and your car now weighs 84 pounds more. That 84 pounds of gas burns to 260 pounds of carbon dioxide, which, when it's dispersed into the atmosphere, occupies a cube 180 feet on its side. But CO2 is invisible, it's odorless. What if it smelled like a skunk? You'd certainly know that it was there. Where does global warming come from? The greenhouse effect. So visible sunlight, visible, is absorbed by anything on the surface of the Earth, and it re-emits the energy as heat, infrared. Some of that infrared is absorbed by the carbon dioxide that's in our atmosphere and re-emitted in all directions. And here we see the atmosphere, and here's some of the CO2, and it's sending some of that radiation, that heat radiation, back to the surface of the Earth, warming the atmosphere. And that is why CO2 is a greenhouse gas. In science, you can ask, or in faith, you can ask, do you believe in? Do you believe in Santa Claus or the devil? But as a matter of faith, you cannot ask the question, do you believe in global warming? Rather, you have to look at your data that you have taken from observing the real world and ask whether that data supports your hypothesis. In a laboratory experiment, we can set up a control. Here C is controlled between the experiment and the control to find out the effect of C. But in climate science, the entire planet is our experiment. There is no control. So what we do is measure differences in time. And global warming really has to do with taking weather observations. These are all the individual weather observation stations on Earth, and measuring the long-term worldwide average from all these stations for a very long time, years or more. And the result is a measure of global average temperature, plotted here from 1880 to the present time in the blue line. You see it's going up and up and up, and that increase correlates perfectly with the increase in the atmospheric concentration of carbon dioxide. The carbon dioxide is going up, and the two go up hand in hand together. And as we see, there's actually a correlation not only with the temperature of CO2, but with fossil fuel use. This chart is from 1750 to the present, and in the same period of time, you can see the vertical lines, fossil fuel use has increased dramatically, giving rise to the CO2. Yet over 1,000 years, CO2 and temperature were flat until the Industrial Revolution. CO2 in the atmosphere we can think of as a bathtub. A bathtub filled with CO2. Burning fossil fuels adds more CO2 through the faucet, but the drain is closed. It doesn't empty. It remains filled for at least 100 years. At the beginning of the Industrial Revolution, it was 280, and now it's 390 parts per million. So in addition to the temperature curve that we saw a moment ago, the effect of, over time, of global warming has been an increase in sea level, a decrease in snow cover over the northern hemisphere. And this has led, in addition, global warming has led to increased frequency of extreme weather events. In green, number of storms from 1980 to the present. In blue, the number of severe floods. And in yellow, the number of heat waves, droughts, and forest fires, wildfires. And you see that over the 30-year period, they've more than doubled. Now, those are observations, but in fact, climate scientists create climate models to predict what the effects of global warming might be. The black line is the same observed temperature effect, and if we try to predict the temperature omitting the increase in CO2, you don't predict it. But the pink line predicted satisfactorily, and so we know that the climate models work. Now, if we project the climate models into the future without adding any more power plants, no more power plants, no more cars, just the ones that exist at 2010, you're still increasing CO2 because they have to be fed for 40 years, and you're increasing temperature. But in fact, we're actually increasing our use of fossil fuels every year. Each year we're burning this much, the next year we're burning this much, projected out to 2035, it's still going up, adding to that CO2 bathtub when this is all burned. So the CO2 bathtub is going to keep on filling up indefinitely as far as we project. The result of all the global warming by the models is by the end of this century, compared to the 30-year period, 60 to 90, the temperature over the northern hemisphere is expected to increase by as much as 8 degrees Celsius. The only way to prevent that is to try to cut back on our emissions of global warming, and the only region that's doing that is the European Union. They have in place a plan to reduce emissions by 80% by the year 2050. But even during that time, of course, this is still being added to the CO2 bathtub. So if we continue as business as usual, our annual emissions of CO2 is going to increase. Under business as usual, the atmospheric CO2 bathtub keeps filling up. We'll have more extreme weather. We'll have climate models predicting seriously worsening consequences. So we really need to eliminate emissions in order to stabilize CO2 as much as possible. So these scientists did this experiment that if you drop the frog into boiling water, he jumps right out. But if you put him in warm water and heat it slowly, the frog just swims around until he's cooked. What's the point of that experiment? Beats me. Scientists, go figure. Probably the same ones studying global warming.